Alright, what's up YouTube? My name is PureUnstable and today we're going to be learning some Java. When you first open up Eclipse after you first download it from the Eclipse webpage, let me just go there now. Oops, not new Eclipse. Cancel. Eclipse webpage. They are eclipse.org. And at the time of this video, you just hit download. It takes you to this page. You just want the Eclipse IDE for Java EE developers. Depending on what your system is, you want either 32-bit or 64-bit. If you're not sure how to check that out, if you right-click on your Start menu and you go to System, once it opens up, it'll tell you System Type 64-bit operating system. That's what you want to get, whatever that says. If it says x84, it gets 32-bit, or if it's x64, get the 64-bit. Once you download that, which I already did, you just run it. You set up your first workspace. You can set it to any folder. You'll get this welcome screen. After here, just close out of that. We won't need that anymore. Once you get here, go to New Java Project. It'll create a new project for you, and this is essential for any project you do. You need a Java project for it. I'm just going to give it a name. I'm just going to say YouTube _ Java. We'll start with data types. And then it's just going to let you select which Java you want. I'm just going to leave it alone at the Java SE 1.8, which is the newest as of right now. We'll just create separate folders for sources and class files and just hit finish. After here, you want to open this up. You'll see a source file. Right click on there. You do this one of two ways. I'm just going to take you through the longer way just so you guys know. It's going to be package. A package is essentially a folder, but to Java, it's more or less more like a specialized folder. Right now, packages are normally made with all lowercase letters, at least starting out. So let's go ahead and name this data types, if I can spell. And you should see a white little box. That just means there's nothing inside the package. I just want to make a new class. The class is what every single Java program needs. It's where all the essential code goes. In here, we're just going to name this integer. Start with that for now. In order to let it run by hitting the run button, you need to do public static void main strings arguments, and just turn off the inherited abstract methods. We don't need that right now. Alright, in here you'll see the to-do auto-generated method sub. That'll happen whenever you let Eclipse make you a method, which is this body right here. This is a method, and this is the class. Instead of class, you have different methods, but I'll get into that later. That's more upper level. So in here, in order to make any kind of data value or data type, as this is called, you need to define what you want to make it. For instance, think of any data type as some kind of box. Let's say you're moving, you have all these boxes. If you don't write on the box what you are putting inside of it, you have no idea what's in there. And that's exactly what a data type is supposed to do. It just tells your computer what is inside of this variable. So we're just going to tell it that it's an integer, which is done by int. And we're going to name it. This is name in a box. We're going to name this number. From here, you can either put a semicolon. It's going to just tell it that there is nothing inside of number right now, or you can actually give it a value. So I'll do that down here. We give the number 1 equals 0. So now number is not defined. This number here is not defined because it has no value, but number 1 here sure it changes to 1 so it's not as confusing, has a value of 1. Now, some errors you might get sometimes if you have different variable names. Like let's say you do, while you're writing a project, you put number like this. This number here, because there's different cases in here, it's actually a different number than this one. It's also not good practice to have any variable with caps unless it is a constant value, which is done with final number. Yep, there we go. The number now is a constant value, so we'll just mark that as 10. And no matter what happens, when you run a calculation through Java that includes this number here as a constant, it will never change the value. Now, it's not good practice to try to change the final value for a constant, but you won't be able to regardless. So let's just do some kind of number crunching or whatever. So since number does not have a value, we'll give it a value. So number is equal to, let's say, let's do some small caps. Number is equal to, we'll give it the value of 0. So right now, number is now 0. Number 1 is going to equal, we'll add, actually let's do, yeah. Number 1 is equal to, we'll do number 1 plus number. So what this is saying here is that the value of number 1, which is 1, is now going to be replaced with the value of number 1, which is 1, plus the value of number, which is the final value of 10. So this is going to equal 11, which is not double. It's going to equal 11. This / here is actually denoting a comment. That just means that it is not going to be processed by Java, and it's not going to ever come up in the code. It's just for our own sake of knowing what it equals. So number 0, actually do something another way. For instance, this number 1, I have number 1 equals number 1. You can actually do it a different way. Number 1 plus equals number. But what this is saying is exactly what's up here. It's saying that number 1 is equal to number 1 plus number. I'll put that here, which is equal to the double, 1 plus 10, which is equal to 11. Same values here. This prefix, put a like on the term. It's like a pre-operation. I cannot remember what the term is for the life of me. I'll throw out the comment, or not the comment, description, once I remember. But number 1, you're saying that to plus equals, so you're adding itself, the number of itself, to number, and then putting that back on number 1. It might sound confusing, but I'll just show you instead. In order to put anything, for instance, if we run this right now, nothing's going to happen. There's just going to be a blank screen. Oop, there's a warning here. Not used, yeah. So nothing's going to pop up down here. A console will pop up if something's going to be said or done, but nothing's popping up now. It's just saying that I am not doing anything with number. I just instantiated it here. So we're going to change that. We're going to make something pop up there. In order to print something to the console, we're going to do system out. What this is saying is that the system, which is the computer, touch screen, I'm sorry, touch the screen. System, which is the computer, dot out which means you want to output something. It can be anything from the keyboard to something on the screen to really anything. So system.out, you want to tell it what to do when it's shipping out. You want to print with a lot of different options. You can do any of these, but what I normally do is print line, LN, and here you're going to want to do the parentheses and another semicolon. Forget to say a semicolon has to end every line. That just tells Java that that's the end of the line and to start going on to the next item in the program. So in here, if you want to have any text be printed, you have to put that in quotes. So in here, we'll just do, if I can use my numbers, find my arrow keys correctly, what to do, number 1 is equal to the space. The space is going to tell Java to put a space between this and what you're putting next to it. If you put a plus, it's going to put both things together. So we're going to both the left side and the right side of the plus. So we're going to put number 1. And what that's going to tell Java is to print something that looks like this. Number 1 is equal to 11. I'll show you that in a second. Now, when you have something like number 1 here, and then again number 1 here, you're replacing the value of number 1 the first time, so this value is being replaced by the value down here. So it's not going to pop up since, I'm sorry, it is going to pop up like that. Let me change what I was about to say. So we're going to use number 1 to equal 1 again. But what actually happened before I said that, we'll comment this out just so I can tell you what was going to happen, was since number 1 here was equaling 11, I'm sorry, I really messed up. Number 1 here was going to equal 11. I was doing plus equals, so this the set value of number 1 was going to be 11. So plus equals number, so it's actually going to add 10 to 11. So let me change that here. 10 to 11, which is going to be 21. That's what it's going to pop out. So I'm going to show you what that looks like on the console. Print line. Number 1 is equal to, oops, none of that. Number 1. So this is going to print number 1 is equal to 21. Now, if I copy this set of instructions here again, I should show you the difference. Keep that here. Get that out. So, if I uncomment this, number 1 is going to go back to equaling 1 like it did at the top here. Oops, right here. So number 1 is equaling 1. So number 1, which equals 1, plus number. So it's going to be what I originally was saying was 11. And I'll print that just to show. So this, oops, got a slash in there somehow. This right here is going to print out number 1 is equal to 11, just like it did up. Number 1 is equal to 11, just like it did up here. I'm going to delete up this comment because it's not needed. Save this. We'll let it run. So like I said, number 1 is equal to 11. Number 1 is equal to 21. Number 1 is equal to 11 again. Now there's something else you can do. Like you can do any operation you want. You can do division, multiplication, addition, subtraction, anything you want. I was just doing all addition here. But something interesting about an integer, which is what we're using again, is that there's this thing called integer division. Now an integer cannot have a decimal place, since an integer is exactly what it sounds like, an integer. It has to be a whole number, and it has to be between different bounds, but I'll get to that later. That's more higher level, again, like I was saying before. So all you need to do for this with integer division is when you divide two integers together, you're going to have a whole number output. So it's going to completely take off the decimal place. For instance, if we take, I'm going to let number equal, since it's 0, I'm just going to replace it with this. Number 1 divided by number. Now this is going to tell Java that it wants to divide 1 by 10, which is theoretically supposed to equal 0.1. It's going to truncate that to 0 again. So I'm going to throw that into a system out. There we go. Now I'm actually going to add a new integer up here. Int number 2 is equal to, make that 3. So at number 3, just so there's no confusion. So I'm going to now make number equal to number, which is equal to 10, divided by number 3, like that. This is going to equal 10 divided by 3, which is actually supposed to be, what is that? Goes in evenly 3 times. It's going to be 3 point something or another. It's going to put a bunch of these. That's going to truncate it to 3 because there's no decimal places. And I'll show that here. Number equals number. Go ahead and save this again, and I'll hit run. So like I said, number is equal to, oops, that went up a different way. Number 1 is equal to, what's happening here? 1 divided by 10, it's coming out as 1. So, like I said, it does truncate sometimes, other times it does not. This is one of those times where it's actually coming out to 1. So integer division is not always the best thing to use, because sometimes it does that kind of stuff. But sometimes it does work out correctly like it does here. So that's really it for integers. Hope you like this video. Hope it clarifies some things. And I'll be doing different data type in the next episode. So see you guys for that one. If you guys like this, enjoy.